Drip irrigation opens new opportunities for improved irrigation management. With its high water use efficiency, it generates remarkable production increases, even under marginal soil and water conditions. Drip is gradually replacing other irrigation methods, with poor control of the amount of water applied and the uniformity of water distribution. Irrigation methods where water is applied to the entire area. Also replacing methods in which a large amount of the water is lost to the atmosphere by evaporation. The unique characteristic of drip supplies water directly to the roots developing in the wetted soil volume. Drippers are available with a range of flow rates suitable for various conditions. Common to all of them is the formation of a limited wetted volume. Each dripper along the line delivers the same amount of water, and therefore we get similar wetted volumes below each dripper. Let us first demonstrate the principle of operation. This type of dripper is placed inside the pipe. The idea is to cause high friction by flow through a long labyrinth, thereby reducing water pressure to get a low flow rate. A different model. Here also, the flow path results in controlled reduction of the pressure. The labyrinth is designed to reduce clogging and produce an accurate flow. Young mango plants in the desert are drip irrigated. They are protected against hot winds. Irrigation here is very efficient. The area between the rows remains dry and free of weeds. Water reaches the plant roots directly. Let us observe the soil profile, the wetted volume. A water-saturated area develops around the dripper. Through capillary force, the water flows in all directions, but downward flow is increased by the force of gravity. The wetted volume is gradually increased, while water content is reduced toward the margins. Within the wetted volume, there is optimal water absorption by the roots, a high level of water availability, and excellent aeration. The size of the wetted volume is determined by several factors. Sandy soil has a coarse structure. The infiltration rate is high. The horizontal flow of water is limited. Gravity is the dominant force, and the wetted volume develops vertically. On the other hand, heavy soil has a fine structure. The capillary forces distribute water horizontally over a larger distance. Another factor, the flow rate of the dripper. When it is 2 liters per hour, it forms a small saturated area. And a larger one when the flow rate is 8 liters per hour. The flow rate and the soil conditions determine the final size of the saturated volume. However, the amount of water application has a limited effect. In the soil, with the low flow, the horizontal distribution is small compared with that of the higher flow. The wetted volume formed by a single dripper may be sufficient for the roots of a young tree. But a mature tree needs a larger wetted volume, supplied by additional drippers along the line. The distance between drippers should ensure overlapping of the wetted volumes along the drip line. There is a continuous wetted volume for the roots of the mature trees. Thus, one can control the development of the roots in the wetted volume along the rows, while the rest of the area remains dry. Also in a vineyard, the area between the rows is dry, but along the rows it is wet. The same with date palms. Roots are concentrated in the wetted areas. The irrigation here is with the button type of dripper. Regardless of the size of the plant, it is always possible to irrigate by drip. The number of drippers per tree is determined by soil conditions, dripper flow rate, and characteristics of the plant root development. When the roots are shallow, as in banana, 2 drip lines per row are generally practiced. Laying lines in row crops. In this case, there is 1 dripper line for 2 rows of cotton, which forms a continuous wetted volume for root development. Similarly in maize, 1 line for 2 rows. Adopting an appropriate cultivation practice, like planting in paired rows, maximizes the benefit of drip. Another example. A number of plants are placed close to each dripper. Each dripper supplies water to a definite number of plants. By adding a line and increasing the number of drippers, we can provide a dripper for each plant. Securing the line is important to ensure that the water of each irrigation reaches the same wetted volume whether the plant's roots develop. A high level of control of irrigation may be achieved when each plant has its own dripper, but this is limited to conditions where it can be justified economically. The exact location of the dripper is important in high-density crops with shallow roots. Otherwise, there will be poor plant development between drippers or the lines because of lack of water or salinization. Salt accumulation may sometimes be observed around the margin of the wetted area. In the wetted volume, there is a relatively salt-free zone, but in the margin, there is an accumulation of salts carried by the water. We can see this on the soil surface. This occurs when irrigation is with brackish water, or there is an excess of fertilization. Fertigation is essential to get the maximum benefit from the drip. Fertilizers are supplied with the water directly to the roots in the right amount and at the right time. In the wetted volume, phosphorus accumulates around the dripper because of poor mobility. The potassium to a larger distance, while the nitrogen, which is highly soluble, moves freely with the water. Where there is an excess of fertilization, salt accumulates in the margin outside the root system. In crops with shallow roots, the irrigation regime should be frequent, small applications. For crops with deeper roots, larger applications with greater intervals. In perennial crops, due to the rainfall, roots may develop outside the wetted volume, but their activity diminishes when the moisture is exhausted. The irrigation regime adopted will affect the depth and density of the roots. With drip, one can also irrigate under plastic film mulch and maintain a larger wetted volume due to reduced evaporation from the soil surface. The plastic film mulch can also serve as thermal sterilization by wetting the soil through the drip system under the plastic. The use of an irrigation controller enables efficient operation and effective management. Pre-planning ensures the delivery of water and fertilizers directly to the wetted volume of each plant. Using appropriate varieties, suitable cultivation practices for drip, and good management throughout plant growth contributes to good plant development. With many crops, drip irrigation increases both quality and quantity of yield, with significant savings of water and fertilizer. Drip irrigation allows us to incorporate marginal soils with difficult topography into the agricultural development cycle. Ornamental landscape crops grown on steep slopes and in gravelly soil can also be irrigated efficiently by drip. Drip makes it possible to supply water to a limited volume of soil for each and every plant. Understanding the factors controlling the wetted soil volume is the key to the successful introduction of drip irrigation.